My name's Jodey Hogeland. I'm the global technologist within ISG, like a part of the same org as Scott. But I have a particular focus on PowerStore globally. So I've been working with the product. This is actually something that we've been working on for several years when it was in concept phase, and then actually bringing it to market about 2.5 years ago. And so this is the fastest growing storage product in Dell Technologies history. I know Stephen mentioned, we're the largest storage player on the planet. So it kind of translates over to the fact that this is the fastest growing storage product in any storage vendor's history. We've amassed thousands and thousands and thousands of implementations over the past 2.5 years, really targeted at being able to run any type of workload in a very condensed architecture. It is based on a dual controller concept at its core appliance level. We call the arrays, think of the individual arrays, we call them appliances, and within the appliances you have 2 nodes. So you've got dual nodes in each appliance. You can call it an array and storage controllers, but that's our terminology as an appliance. And then in the appliance, you have node A, node B, and that's your 2 controllers. So supporting your traditional based workloads, block-based fiber channel iSCSI capabilities while simultaneously supporting file. And then next gen capabilities with NVMe over fabrics, whether that's fiber channel or TCP, connected with a heavy emphasis, as was discussed earlier, on NVMe over TCP. We launched that capability in collaboration with VMware back in February of this year. And I just wrote an article on this, so that on my LinkedIn profile under articles, there's several articles on ransomware integration and protection, some of the stuff Scott was just talking about with Cloud IQ integration, but also simplifying NVMe, specifically NVMe over TCP. If you're running iSCSI today and you're running VMware 70883 or higher, and you're running PowerStore, like, why would you not, right, do that? So it's fully supported, fully capable, and gives you some very efficient capabilities. So really running any type of workload. We've got customers in the financial sector on PowerStore. We've got customers in the healthcare sector, highly virtualized workloads, container-based deployment methodologies and architectures. So fully autonomous environments, whether that's Ansible, vRealize, ServiceNow integration, whatever it is that you want to do, we've got that level of capability from a multi-protocol accessibility and a deployment methodology. Now, PowerStore is developed on a container-based methodology, so that the actual PowerStore OS is actually running in the context of containers. So just kind of for an example perspective, let's say this represents the data path. That's actually running as a container. Let's say this represents the file, the NAS services, the file capabilities. That's a 64-bit scalable file system. That's actually running as a container. I met with one of the world's most recognizable logos yesterday, very massive global company. And their perspective was great. You have a unified array. They're looking at PowerStore very strategically and said, that's cool, you do NAS, but I don't need file. These workloads at these hundreds of places are going to be block-based environments. We do other things, for our file integration side of the house and file capabilities. As you just don't deploy the container, right? So it's like literally when you stand up the array, you get to choose block optimized or unified. So it's not a license. It's not an orderable SKU or something like that. When you deploy, you get the choice, I deploy or not deploy. So it's very simple to optimize PowerStore for 100% block ecosystem, or if you want unified, deploy unified. And now you're running, file services and fully integrated into the architecture. The support mechanism, so the phone home capabilities, things like that, runs as a container.
I have a quick question. Can you change your mind over time? I mean, so if I start block only and after 6 months I want files, can I, without any disruption,
deploy unified first, right? So not today. So today, that decision is made at the time of implementation. If you think there's a chance I might want to do unified, deploy unified out of the gate. And I will tell you that the majority of systems we have deployed are in unified configurations for that reason.
Why are you giving the option then? I mean, so if it's if it is a disruptive change, and I mean, there is no advantage to have block only.
There is an advantage. Any unified architecture on the planet, whether it's us or anybody else,
Okay.
there is an associated overhead to run those file services, even if you're not using them. Right. So in our, like, for example, there's one competitor out there in the industry that created an entirely different SKU. It's the same box, it's running the same OS, but from manufacturing, they disable the file services. But you have to, that is a complete custom order that can never be deployed in any other way. For us, it's the same order, same SKU, same OS. When you get it on site, you just get to choose how you want it. So there is an associated overhead with turning file services on. You're talking, you know, a handful of percentage points on a CPU clock cycle. But if you don't want that, you don't have to have it, right? It's completely up to you.
Okay, thank you.
Good question. Any other questions on the container deployment methodology? So basically, we've got these different services that make up a core storage array are running containers. They're actually containers deployed within the architecture.
Jodey, just to be clear, it's not like you're running Kubernetes under the covers in PowerStore.
We're not running Kubernetes under the covers on PowerStore. We are using a
container-based storage software solution.
Container-based methodology, and these different pieces get deployed as containers. Now, why does that become important? One, you see a little bit of the flexibility here with, hey, I can deploy file services or not. Okay, yay. The bigger side of this is really kind of the pace of deployment and the pace of innovation. For example, we're going to talk about the 3.0 release that we just started shipping a couple of months ago. There's 120 plus features in that software update. So 120 plus enterprise capabilities in one software release, but that's because we're working, the engineering staff is working in the context of microservices in each of these components and fields. So it makes the development cycles a lot easier.
Right, but to be clear, you're talking about containers inside the device. It has nothing to do with workloads running containers, right? So just to be clear, the two are separate.
So the
Frederick, it is a brilliant point that you bring up. So a lot of customers, I do have to do some explaining there if I'm the one giving a presentation and they want to understand what is this container-based OS, because there is the concept, you know, here within the storage array, you know, we're running, you know, PowerStore OS inside of here, and within the context of PowerStore OS, these services are getting deployed as a container inside of there. That is not customer managed. It is not customer manipulated. The customer doesn't even know realistically that it's even running that way, right? It's completely transparent to the user. So that is completely separate and different than saying, hey, I'm running, you know, a Kate's cluster out here where I'm leveraging storage that's running containers and then deploying container services, you know, whether that be in the cloud or, you know, at other locations. You know, that's a complete user side versus internal side, completely separate. Frederick, does that make sense? Answer your question?
Yeah, it does. And then maybe a follow-up question. I mean, when we talk about modern workloads, building and running containers, do you see block/file more dominant or more object being dominant?
So it really depends. So take, for example, a customer running VMware Tanzu with, you know, Kubernetes integration via CNS or cloud native storage. All of that from a VMware perspective is predicated on vVols and vVol accessibility. And in some cases, customers that have been defined using NFS for early adopter Kubernetes deployment methodologies on file. That's a lot easier context to manage than saying, hey, I'm going to create a VMFS instance and create a VM and then create storage associated with that from a VMFS or a block context. That could be very difficult to do. However, if you go into the world of like OpenShift or you go into the world of some Rancher or something else that's doing Kubernetes-based orchestration and automation, you can absolutely just make a block service call, persistent storage call to create that volume, spin it up. So I would say it's kind of this balance between how long have you been doing container-based deployment methodologies or Kubernetes integration, they started off in file typically because it was very easy and it like they didn't care, right? And some of that thing is some of those things are changing as technology moves forward. Like NVMe over TCP, for example, is probably gonna create a lot of nuances and cycle developments outside of that. So I would say it's kind of this delicate balance of how long have you been doing it and when did you start doing it, and that kind of gives you the ability to say what's available to me now versus what was available to me then. And PowerStore kind of delivers on all of it. So it doesn't really matter what you're wanting to do. We can deliver on that. Is that helpful?
Yes, thank you.
Great. So taking this PowerStore array, we can cluster PowerStores. I know getting into cluster, especially with this audience, can be a bit nuanced, but let me define our position here within clustering. You saw PowerMax. That's a tightly coupled cluster, right? So tightly coupled being all InfiniBand connected. It doesn't matter where the IO comes in. You're going to get the same response time because you're on a low latency RDMA fabric, across the stack. But in the world of PowerStore, it's more of a loosely coupled, or what some people might define as a federated cluster. So here you see like a PowerStore 5000 series, 3000, 1000. We can mix and match appliance types within the cluster. So these are your active controllers. Each of these has a single storage pool. So an array will only ever have one storage pool. It's very simple, very straightforward, very easy to use. And this gives us the ability within the cluster to do a few different things. One, the cluster is connected with 10 gig or higher, 10 gig Ethernet or higher. We are not we're not stretching a volume. So for example, a volume creation, that volume will always live on one appliance. We do not span a volume across multiple appliances because we do not have that low latency interconnect. We're not trying to do IO retrieval to a host from one appliance versus another appliance. The data is localized to an appliance within a cluster. That 10 gig network is top of rack switching, customer supplied. So we don't require any kind of proprietary network or dedicated network. We can use customer top of rack switching. That's going to be the cluster heartbeat, cluster management. All of these appliances are managed from the exact same interface. So you actually get a global view of the cluster. And you also get things like autonomous creation across the cluster. Just kind of, for example, if you wanted to create 100 volumes really quickly, you could say, I want to create 100 volumes and I want them all to be on this 5000 series. Great. But there's actually a drop down in the interface that says auto. So the cluster will then, based on its knowledge and machine learning about the cluster, will say, you want me to create 100 volumes and you want me to auto place them. So I might put 75 here and 25 here, or 25 here, 25 here, 25 here, 25 here. So based on what the cluster is doing, there is intelligence built in from the ground up. This is from version 1 of PowerStore to make deployment methodologies very simple for storage administrators to say, look, I need to spin up 100 volumes. I need to do it really quick. Let the machine learning and the cluster logic handle that for me, and it will auto place those workloads. You can also non-disruptively move these workloads from one appliance to another. So we've got that full volume mobility to say, hey, non-disruptively take this volume here, move it over to here. From a host perspective, that's just a multi-pathing cutover is what it's going to look like to the host. Say, hey, I'm accessing you over here. Oh, all of a sudden that path is not the active optimized path. That one over there, it is over there, and it goes down that path. So everything from a cluster perspective, if you want mobility from appliance to appliance to appliance to appliance from a single host, you do need to make sure everything is zoned, right, or mapped from that perspective. But we can also remove appliances, so we can take appliances out of the cluster. Adding an appliance to the cluster is about a 15 to 20 minute process. We actually have created what's called the discovery wizard. So a user doesn't require some extensive professional services or engagement. They can actually auto discover the appliance. We do have to have power and network, but once we have power and network, we can auto discover that new appliance that's part of that top of rack switch infrastructure. And we can join that, autonomously join that to the cluster. It will check and validate the code version. It will synchronize the code version. It will then bring that appliance online. And then within about 20 minutes, you can start migrating workloads there or standing up new workloads there. So it's about a 20-minute process to make that work. So any specific questions on clustering within PowerStore?
So what's the limited number of nodes, I guess I'd call them, in the cluster? Is it 16, 32, 64, 512?
Yeah, so from a node perspective,
And a node would be a two array, two controller appliance, right?
no. So an appliance has 2 nodes. So it would be 8 nodes or 4 appliances. Think of that as 4 arrays. So it's a 4 array limit in the cluster today for PowerStore.
I got
So
you.
basically what you're seeing on the screen now would represent a fully populated PowerStore cluster.
As far as the enclosure, I guess I'd call them the disk enclosures. How many disk enclosures can you attach to, like, say, a PowerStore, let's say 9,000?
Yeah, so let me show you here. So all of them, this is what's one of the really cool things of PowerStore is they all support the same, right? So from the 500 series all the way up to the 9200, which is our latest and greatest largest, they are all 2 rack unit form factor. They all have the same port configuration options, and they actually all support the same scalability, 90 plus drives per appliance, right? And if you're looking at
mix and match them
in the cluster, yes. Yeah, that's kind of what you see represented here.
Just making sure I'm seeing what I'm thinking. So
Yeah. So think of this as my 2 nodes. So we've got an appliance, right? This is the 5000 series appliance. We've got 2 active nodes, node A, node B. That's our storage controllers. And then internal, we have our internal drive. So that 2 rack unit enclosure is going to house internal flash modules. These are all NVMe through the entire stack. So we've got our NVMe flash modules within the 2 rack unit enclosure. So if we pop the bezel off the front, we're going to see the drives. If we spin it around the back, you're going to see the 2 nodes, right? So from there, we can add NVMe connected an additional 3 shelves per appliance. So it's the 2 rack unit and then a 2 rack unit shelf, another 2 rack unit shelf, another 2 rack unit shelf. So when we're talking about the entire thing, it's 2, 4, 6, 8 rack units is as big as we can make a PowerStore today.
A question for you. I don't see, you guys had a PowerStore version that ran VMs. I think it was a PowerStore T. Is that what it was?
So that's the X.
X, right.
So PowerStore T, think of that as the traditional model. That's kind of what we were just talking about. PowerStore X is the ability to take a physical PowerStore array. There basically is a 50-50 split between CPU memory resources. And in this case, we deployed this actually runs, PowerStore X literally runs ESXi. It runs VMware's hypervisor on the exact same sheet metal of a PowerStore T. It's the same hardware, it's the same sheet metal. And we deploy ESXi directly on there. But in this world of what we branded as AppsON was the ability to run apps or VMs directly on here because it's literally running ESXi. So you have PowerStore OS deployed as a virtual instance, and it is an H8 virtual instance between the 2 nodes, completely resilient within and of itself. But then you could deploy, as many VMs as you want to deploy. That you're really just bound to virtual CPU and memory. And the higher model you go, the more of that you have to play with, right? But that was the deployment model of X. We've had hundreds and hundreds of those deployed. They're typically like edge-based scenarios. Think manufacturing facilities, remote office type deployment scenarios. That's where it's been very popular. The one area of feedback we've received from customers was, hey, I'm not a big fan of this 50-50 split, right? So as a result, they wanted to be able to independently scale compute and storage. And I'm going to talk about what we're doing there in just a moment.
Excellent. Thank you.
Sure. All right. So here's a look at growing the cluster. So you can kind of see from an automation perspective, the graphic here is, hey, we added another appliance to the cluster. That takes about 15 or 20 minutes, right from the GUI, right from the interface. It's a couple of clicks to make it happen. But also there's logic and machine learning that's doing an analysis within the workloads. So that's one of the way that we're distributing workloads across the cluster. If the customer wants us to do that, we will never move a workload, a volume from one appliance to the other without administrative approval. So this is not like a VMware DRS scenario yet, where we're just moving things seamlessly around. An administrator, we will make a recommendation perhaps that says, hey, you will actually be better off if this is somewhere else, right? And the user can say, yeah, I want to do that, right? And so this is kind of an example of that scenario in what you're seeing here. So let's say we've got a volume that's running here and it starts filling up and maybe it hits a threshold. Let's say it gets like 85% full. That's going to throw an alert. So right in the storage interface, you're going to get an alert. You click on that alert. There's a dialog box, and that dialog box will say, hey, Jody, you've got 8 days before this runs out of capacity. You've got 7 days before this runs. Like, do you want, and then there's a link called assisted migrations. Like, you want me to handle this for you? And you say, yes, you check that box. It's then going to pick that workload up and move it to another appliance in the cluster that it knows can handle that workload for you. Now you can always go do the 6 clicks to move it yourself, right? It's a very simple process to make that happen. But this is the autonomous capabilities of notifying you that there's a challenge, and then right from that interface saying, hey, I know you know what's best for me. Go ahead and do this, and it'll kick that move off for you to another appliance in the cluster.
Hey, Jody, is that being done with Cloud IQ, or is that something that's internal to the PowerStore solution, or?
That's internal to PowerStore. So within the cluster, the PowerStore, what we call PowerStore Manager, that's the user interface, right? Is PowerStore Manager. Within PowerStore OS and PowerStore Manager, within the control path and the data path, we do have triggers and analytical aspects from a machine learning perspective. So there's a lot of, I wrote an article on this. So if you screen my LinkedIn profile, go to articles. I actually I did a write-up on some of the autonomous operations for PowerStore. These are things that are just native to PowerStore. There's a lot of cool stuff Cloud IQ does, and I wrote about some of those as well, like the external analytics of what's going on with a workload or ransomware integration and protection, et cetera. But this is all internalized. This is completely internal to the logic of PowerStore by itself. All right, so this is what I was talking about. So the question about PowerStore X, note that we did have that 50-50 split because we were dedicating 50% of the resources to running the storage environment and 50% of the resources to run the user's compute environment or the actual VMs from a VMware perspective. We actually had a couple of partners, and this was really born out of that. There was a couple of very high-end metal level partners for Dell Technologies that I met with, and they said, hey, VxRail has just come out with these dynamic nodes, right? So these are compute-only nodes that do not have storage. So there's no vSAN, there's no vSAN licensing. So they're very cost-effective nodes, right, to put into an ecosystem. And PowerStore, the Dell Technologies storage portfolio, PowerStore, PowerMax, and also Unity XT, we can support connectivity to these VxRail dynamic nodes. VxRail is our product, and our storage arrays can be supplemental storage to these storageless nodes or dynamic nodes. So in this case, a couple of these partners have actually built business practices and go-to-market strategies for customers that are really on the wagon of HCI with VxRail, so specifically in the VMware context, and saying we like the idea of being able to grow just the compute instances dynamically, and then they'll take like a PowerStore 500. So we support a minimal. It's a 6-drive config is the smallest config for every flavor of PowerStore. So you could take a PowerStore 500 with 6 drives, so very cost effective, but yet have it directly NVMe connected and have high performance single drive scalability storage with all of these cool bells and whistles from a storage perspective, but now abstracting the HCI component from that. And what we actually launched this at VM Explorer. Dell Technologies did a booth session where we're going to integrate lifecycle management into VxRail with the supplemental storage here, PowerStore, so that customers can have lifecycle management visibility into what they're doing from an upgrade perspective in dynamic nodes, and then have that integrated into the PowerStore ecosystem from a management perspective as well. So that gives customers kind of the best of both worlds. You've got this dynamic scalable CPU ecosystem, and you've got this dynamically scalable, high performant, low latency storage ecosystem. And you can go in the most cost-effective configurations and then grow from there if that's what you want to do. So that's what's going on with, we've kind of branded this. Think of this as like the next iteration of AppsON is now Dynamic AppsON, right? And kind of growing out that capability. All right, so we launched the 3.0 software. We kind of pre-announced this at Tech World this past May, but as Scott mentioned, back in July, we actually started shipping this. So if we kind of go around the wheel of fortune here, we'll see increased scalability. So this was, the introduction of the NVMe-based expansion shelf that allows us to use, our largest drive in PowerStore today is the 15 terabyte flash module. So that allows us to extend that, which gives us overall greater capacity and scalability. So we've got that capability now building out in PowerStore. All the 120 plus new features here. So that's kind of that rapid pace of development that here we are just 2.5 years into product life, and we've got a lot of really cool stuff that we're doing and integrated in the security aspect, external key MIP, FIPS certification end to end. The new FIPS thing, we've been using FIPS 140-2 level 2 certified drives. We use self-encrypting drives in PowerStore. That's been that way since day one. We were encrypting NVRAM, but now in Gen 2, the NVRAM modules are not just encrypted, they're actually FIPS certified hardware devices. So that's the difference, right, between the NVRAM modules that we're using. And then hardware root of trust that Scott touched on. This is now across our enterprise portfolio for storage, PowerMax, PowerStore. You see this integrated into PowerFlex capabilities, and Scott touched on that, so I won't reiterate it. More VMware integration. As I mentioned back in February, we literally co-engineered and brought to market NVMe over TCP in collaboration with VMware. We also are the first to collaborate and co-engineer NVMe over vVols for Fiber Channel with IP coming. We can't get into roadmaps, but no, we're not stopping, and we do have collaborative engineering. We've got now vVol full SRM and vVol replication integration for PowerStore, and then end-to-end visibility got enhanced. So if you haven't taken a tour of the PowerStore Manager GUI, the actual interface, there's YouTube videos on this. I'm more than happy to peel off and do a session with you at another date. But from PowerStore GUI, we can join vCenter. So we also have the VMware plugin, like you drop the VSI plugin into vCenter, and you can see and tell PowerStore to do things, right? Everybody kind of does that. But here, you can actually join PowerStore to vCenter. You can log into vCenter, and then we can literally show you VM level granularity, VM performance statistics, VM IO statistics for memory statistics for the virtual machine as it pertains to what's going on in the storage and what's going on the compute side. So it's not just a one-way street from VMware to storage. We can go either way. And we've enhanced that. We launched that capability with vVols from day one. So when we launched PowerStore, we had full vVol visibility into the virtual machines. Now with 3.0, we've extended that to VMFS. So we can actually drill down into VMs that are running in the context of VMFS data stores, and also VMware over NFS data stores as well. So like really nice, cool granularity there, and visibility natively into VMware ecosystems. Anytime upgrades. So this is our ability to allow customers at the point of sale to go into that operational model to say, hey, when the new stuff comes out, I want access to it, right? So we just launched the new controllers. So we've got customers now in prep to do those non-destructive upgrades from Gen 1 to Gen 2. So we're going to start, here in the future, we're going to start to see those customers taking advantage of that and going through that controller replacement from Gen 1 to Gen 2.
So Jodey, those are data in place upgrade kind of things, right?
Correct. Yeah, it's the same enclosure, same chassis. So this would just be swapping the node. File services enhancement. So we talked about that file-based container. So the file capabilities of PowerStore. In the initial releases, we were restricted to 2 specific ports that we allowed NAS services or protocol IP connectivity to run on. That's now available on any port. We also introduced file level retention or compliance level retention. So compliance locking on files, retention policies on files for audit purposes. CEE and KEPA, so this is integration into, say, third-party ransomware detection audit tools is there. And then VMware over NFS enhancements. The enhancements are basically VAAI primitives for NFS. So we brought VAAI integration for customers that want to leverage VMware over NFS data stores. We also streamlined the creation of a NFS data store. So in PowerStore Manager, when you go to create a file system, one of the options, there's 2 options, general file system basically, or VMware over NFS. So you can select that, and then basically from there, all of your best practices and things are getting applied from a VMware over NFS perspective. Data mobility enhancements, we introduced native integrated Metro. We'll talk more about that in a moment. File-based replication, so native file replication is now there. Multi-array block and file import. So, we did some enhancements here. From PowerStore, we can discover all of our arrays, right? So we can discover legacy equal logic arrays. We can discover SC series or former compellent. We can discover Unity, Unity XT, Extreme IO. Now we can discover VMAX, PowerMax, and we can import those workloads from PowerStore Manager from those arrays directly into PowerStore. And we also did our first introduction of third party with NetApp. So you can actually discover NetApp block workloads and ingest those into PowerStore right from PowerStore Manager. And then of course the new controllers, right? It's basically, all it is a CPU bump and the 100 gig connectivity option. We now have a 100 gig card. So here you'll see version 1 nodes on your left, version 2 nodes on your right. The only difference is CPU. That's it, right? So it's just a CPU bump between the two. Notice that the 7000 series, it goes away. Reason being is we actually can deliver the 9200 at a lower cost. So it, like, the customer's getting a 9200 series performance for basically kind of the cost of a 7000 series. So we were able to reduce the cost and then eliminate something at the top end. There was no need for us to be selling 2 products at the top end when they're going to get better performance for lower cost. So we took the 7000 out of the picture. So that's the only reason that is the way that it is. Interestingly enough, it was kind of a, hey, buy it while it's hot kind of deal. So customers that were in our Anytime Upgrade Select program, if they purchased the 5000 series and had our Anytime Upgrade Select plan, that means that they don't just get the 5200. That's Anytime Upgrade Standard. Anytime Upgrade Select means you go one higher model from where you are. So customers that had the 5000 series with Anytime Upgrade Select, they're actually going to be going, getting an upgrade up to the 9200. So pretty cool. It was like, I was telling people, get it now. It's a kind of a once in a lifetime deal. But that's what's going on with the new nodes and the new.
So Jodey, the 100 gig is front end connectivity or the back end connectivity or both?
Both. So we support now the 100 gig IP connectivity that you're seeing on your screen here. That's in relation to host connectivity. But the introduction of the NVMe expansion shelf is actually 100 gig connectivity as well. So in the 1000 series through the 9000 series, there's actually a 100 gig module that gets inserted. That 100 gig module is what connects the NVMe expansion shelves. And internally, we're actually using Rocky protocol between the shelf connectivity over that 100 gig network. But it's basically a direct connect. It's not switched or anything. Just that's the way that it works.
Can you talk a little bit more about hardware root of trust? Because I find that I must have missed some meetings or something. This is the first time I've really heard of it. Is this something relatively brand new? Are your competitors, collaborators actually using it?
So to my knowledge, I've been doing this a while, you can tell by the silver hair. Dell Technologies pioneered this. Scott mentioned this with PowerEdge Server back 2017-ish.
Okay.
That was the first time that Intel integration and hardware root of trust came into play. And basically, this is a digitally signed instance of the software that's going to be running on that platform. It's a digitally signed instance of the software from engineering. So this is not like MD5 checksums. This is a level beyond that of digital signature within the software package. And then that directly binds to the capabilities of these Intel chipsets that can support this. So we prevent anybody from manipulating the software stack running on the array, talking about the OS distribution, in this case, PowerStore OS or PowerMax OS, for example. It will not come online. It literally will not be allowed to boot if something has been manipulated. And that is a physical binding between the digitally signed software and the Intel chipset. So hardware root of trust is only available in PowerStore on the Gen 2 nodes, on the new nodes, because we need that Intel chipset. The Gen 1 that we were running in PowerStore Gen 1 don't support that capability. So that's something new in Gen 2. But it is, started with PowerEdge in the industry. We've rolled it out to PowerMax, PowerStore, PowerFlex. And to my knowledge, I don't know of an other player in the industry in the storage landscape that has that technology. This is where it starts, right? It's actually going to get better. Think of in the future of where things would go with a customer saying, hey, okay, well, this is where I started. When I initialized the array, it looked like this, but what happens when they do upgrade? They add an IO card, or, we know global supply chain is a global supply chain. People are getting components from all over the world. Who's to say that something wasn't tampered with in a manufacturing center somewhere in a remote region of the world? Now Dell Technologies guarantees that supply chain and chain of custody of the hardware. But now we're taking that to the next level and saying not just the hardware chain of custody, but the firmware and the software that gets loaded to drive those components is going to be guaranteed certified as well.
If we could go back a second, when you were on the other slide, you mentioned like 4 different ways that the PowerStore can connect to different things. You said you can connect it right to vCenter. You said you can see all the workloads for the various different Dell storage products. You said it connects to the NetApps. How are you doing that? Is vCenter a plugin or is it native? Are you using third-party ingestion for the NetApp? Are your other ones going through Cloud IQ? Can you elaborate on that a little bit more?
I can. So let me give you a little bit of detail. The VMware integration is from PowerStore Manager, directly from the interface itself. We're talking about the ability to basically tell PowerStore to join vCenter, to log into vCenter and pull data into PowerStore so that you're actually able to see it. Yeah, we join here. The other piece that I'm mentioning is a different piece, import external storage. And this is a separate piece. If we're talking about the third party, it's an API call. So we are integrating the APIs to make NetApp publishes APIs, Pure publishes API, everybody publishes APIs, right? So it's an open API framework where we make the call into that technology and bring that over. So we do get the single drive scalability that Scott was talking about. So we actually kind of pioneered this with what we call DRE, Dynamic Resiliency Engine. There's a public webinar that I did where we go through in detail the capabilities of DRE. This is how we're doing single drive scalability. This is how we're doing distributed striping across the set. This is what gives us a single pool of storage. We can mix and match drive sizes. We can mix and match drive types. It is very flexible and also provides that same high performance rebuild. So a 15 terabyte module under system load is typically less than 4 hours if the drive was 100% full, which would never happen. So we're typically talking about recalculates or reallocates in a matter of minutes. But when we look at this, standing up to some of the competitors in the industry where it's, hey, you gotta buy a 10 drive pack. You start talking about 15 terabyte modules, 30 terabyte modules, or even larger, that becomes a real challenge. And we've solved for that in our technologies already. We've talked about a lot of the enhancements already from a file perspective. I kind of overviewed these, but the ability to have.
I missed for a second what you were saying. So you can sell a single drive to a customer, and then you can restripe everything just because you
So-
buy a single drive, and then the day later I can buy another drive, and you can restripe everything again.
So I wouldn't classify it as a restripe, Enrico. The way Dre works is so when we drop the data down in that stripe width, when you add a new drive, Dre will autonomously calculate that space and it gets distributed across the entire pool. So think of it as, it's a virtual construct of the RAID concept, right? So we take the physical, we chunk it up into virtual constructs and everything gets distributed. So the stripe width, if a customer is saying, hey, I've got this new drive and this new playground worth of space, PowerStore will say, hey, I'm going to take these blocks that are coming in and write them here first or there first to make sure that I'm completely balanced as you grow the environment.
As you grow, you are balanced, but you don't restripe it.
It's not we don't have to do like a heavy reallocate process every time you do this. We do not do that, right?
Okay, very good. Sorry.
The NVMe side of the house, we've pioneered this capability. NVMe over TCP heavily. The big notice here, I think someone in the room mentioned early when Scott mentioned NVMe over TCP, somebody in the room said, as it should be. We understand that, right? So as the majority of customers today are still fiber channel, but I've met with some of the largest players on planet Earth who have already made transitions to Ethernet-based ecosystems simply for consistency and cost. And that's just the way that they're going. And what this does, if you look at it this is an IDC study, by the way. So this is not something we did. This is an IDC study that does talk about the cost per port. So when you go into 100 gig, particularly, you're 73% faster than current 32 gig fiber channel, but you're 50% lower cost per port. And now you're expanding on the capabilities where, Ethernet in its prior form with iSCSI was very restrictive. It was individual mappings, IQN from the host to the storage. Anybody that did that above 50 hosts is a freaking nightmare, right? Nobody wanted to manage that. So we've actually created a technology called Smart Fabric Storage Software that for the first time in history, no one has ever done this, leveraging Ethernet, high performance, low latency, NVMe over TCP, we can completely autonomously map from storage to network to host in autonomous fashion. And for the first time ever, allow customers an interface to log into to do mapping and zoning with NVMe over TCP. And that's because of the centralized discovery controller capability, the CDC integration within the protocol itself. We're the first ones to really ride into that and create this capability. So this is going to open opportunities, not just in the core data center, but edge connectivity. NVMe over TCP is routable, cloud integration models. So now this is already a happening conversation in native hyperscalers. There is no fiber channel. So now using NVMe over TCP within the hyperscaler context, and we created Metro, customers were asking for it. So now PowerStore within 6 clicks can set up an active data center fully integrated with vSphere Metro Stretch Cluster from a VMware perspective.